welcome to 6.4, Parallel Lines and Transversals. This word transversal is probably new to you, so we need to talk about its definition in a little more detail than we've spent on other definitions. It's a line that intersects two or more distinct coplanar lines in two or more distinct points. So let's look at the next slide for some examples. Which one of these do you think are transversals? Okay, let's look at letter A. It's those are probably parallel lines. Those are coplanar lines. They're in the same plane, and it is intersected by one line in two distinct points. So A fits our definition. B also fits our definition. It is also two or more distinct coplanar lines. Really, you can look at it in every single one of those is a transversal to the other two lines. So this one, even though it forms a triangle in the middle, nothing says that those lines have to be parallel. So this is also transversal. And also letter D is a transversal. We can have more than two. It says two or more distinct coplanar lines in two or more distinct points. So this one we just have 3 points and 3 lines. Now C is the only one that is not a transversal. If you notice, yes, the line intersects both of the other lines, but only in the same point. So that's actually a point of concurrency, and so it doesn't satisfy the definition of transversal. Now we're going to talk about alternate interior angles. I am not sure what your background was before algebra in middle school, but I think that you should have had these definitions in the past. If not, we are going to spend a little bit extra time on this section. Chapter 6 is unusually long, and I think 6.4 is kind of two separate sections in one anyways. So we're going to talk about the word alternate and the word corresponding. So alternate kind of means opposite, okay? So alternate interior angles are opposite sides of a transversal and two other lines. So let's go ahead and look at that. So here are two lines that have a transversal. Now these particular lines are parallel, but if you look at the definition, it doesn't say anything about having to have parallel lines, okay? So if you look, 4 and 5 are interior those two lines. So those are alternate, they're opposite the transversal, but they're interior of the two, in this case, parallel lines. 3 and 6 are also alternate interior angles. So they're opposite the sides of the transversal, but they are between the other two lines. So much like alternate interior angles, there's also alternate exterior angles. So they're opposite sides of the transversal, but they're on the outside of the other two lines. So here we would have, we've already talked about 3 and 6 and 4 and 5 being alternate interior. So we've got 1 and 8 as being alternate exterior. And we also have 2 and 7 as being alternate exterior angles. Last, we have corresponding angles. These are angles that are on the same side of the transversal, and they're on the same side of different lines. So let's look at an example of that. Here we have the transversal, so same side of the transversal. An example would be 1 and 5. Do you see how they're both angles are above the line, but also on the same side of the transversal? we have 3 and 7, and 4 and 8. So again, both of 3 and 4 are below that line, that first line, and 7 and 8 are below the second line. So 3 and 7 correspond, 4 and 8 correspond. Okay, so now we're going to we have 12 angles, okay, and we're going to talk about what angles are which. Okay, so we have to label. So here's asking us what kind of angles are 9 and 11. So first you need to find 9 and 11. Okay, you have to decide, are they on the same side of a transversal? Are they on the same side of the other two lines? Okay, we have to come up with, are they alternate exterior, alternate interior, or corresponding? So go ahead and hit pause, go ahead and give a guess, and then see if you're right. If you said corresponding, you are correct. Okay, the transversal would be the bottom line, the most bottom line, and then they are both on the bottom of the other lines. Now it's very hard to tell this because it's a triangle. These are a little bit tricky, and so I want to walk you through this. Let's look at another example. Okay, so 4 and 12. Let's find 4 and 12. Okay, 4 and 12. Now look, they are on opposite sides of a transversal. And are they both interior or exterior? So since they're opposite, we already know they're not going to be corresponding. So they're either going to be alternate interior or alternate exterior. And if you use your imagination and kind of stretch out those other two lines, you'll see that they are on the interior. So the answer is number 2. Last but not least, let's look at 7 and 2. Go ahead and find them and give yourself a guess. And then pause and check your answer after you have it figured out. Okay, so if you said alternate exterior this time, you would be correct. Okay, so let's break this down. If two parallel lines are intersected by a transversal, then the alternate interior angles formed are congruent. That's the first condition. Second condition would be if two lines are intersected by a transversal in such a way that the alternate interior angles are congruent, then the two lines are parallel. So if you look here, we can now prove lines are parallel, and if we're given parallel lines, we can prove congruency in certain angles. So this is one of those tricky things where it depends on what we're given, on what we're trying to prove. This postulate goes in both directions. That's what biconditional means. Okay, now we have the historic parallel postulate. I'm not sure why it's titled this, but it basically says if you have a line and a point that's not on that line, there's only one line that passes through the point and is parallel to the given line. And eventually we will construct this, but not in Chapter 6. Okay, my bad. I did go ahead and make the slide to break it down for you. So here it is. I've already said everything that's on the slide. I'm sorry, I forgot that I did that for you. So the two conditions of the biconditional statement: if two parallel lines are intersected by a transversal, then the alternate exterior angles are congruent. And if a transversal intersects two lines, so the alternate exterior angles are congruent, then the two lines are parallel. So part 1 is proven on page 228, part 2 is not. Okay, so as you might have guessed, we already have alternate interior, we have alternate exterior, now we have a corresponding angle theorem. So two lines intersected by a transversal are parallel if and only if the corresponding angles are congruent. Okay, example 2 is going to give you the first part of the condition. Okay, so given the angles are congruent, you need to prove that the lines are parallel. And obviously we have the other way around. I also wrote down here exercises 11 through 15. That is going to be your part 2. They gave you all the statements for number 11 through 15. That's what those, number 11, 12, 13, 14, 15 are statements. And then you have to fill in the reasons to that proof. So I think there's two more here. Okay, so if a transversal is perpendicular to one of the two parallel lines, then it is also perpendicular to the other line. Which, if you just drew yourself a picture, you have parallel lines and drew a perpendicular to one of them, that transversal is automatically going to be perpendicular to the other one. And this is also exercise 24 asks you to prove it. So I just kind of put a little marker on there for you. Alright, and last we have your whisk summary. Okay, I know this was a big lesson, and I apologize, but you will not have a video to watch tomorrow or the next school day because this is going to take 2 days. So you spent a little extra time today, and hopefully you'll gain that time on the next school day. So, whisk summary. A rectangle was defined as a parallelogram with 4 right angles. What is the fewest number of right angles that guarantees that a parallelogram is a rectangle? Now I want you to prove it. So come up with an answer for me and then prove it. That means I want you to write a proof. I know we still aren't super excited about proofs yet, but they are, hopefully you're getting better at it. So I want you to practice writing this proof tonight. And the hint that I gave you here is use the parallel postulate. That is the first one that we talked about being biconditional. Okay, and it deals with alternate interior angles. Alright, and I will see you in class.